Hello student friends, today's video is about epidemiological exercises. In the practical exam, you will get 10 marks with statistical and epidemiological exercises. In that, 2 questions will be from statistics and 3 questions will be from epidemiology. So like this, you will have 4 marks for statistics and 6 marks for epidemiology. So in today's video, we'll see about the various types of epidemiological exercises which are asked in practical examination of the community medicine subject. So they will ask you a question or a scenario based questions in which you have to apply the epidemiological parameters and then you have to do the solution. So now start with a simple question, that is calculation of the incidence rate. So there were 100 cholera cases in a village of 9,000 population. Calculate the incidence rate of cholera for the village. So number of cases. So first you write down the given data. Number of cases are 100, total population is 9,000, and to calculate incidence rate. So I want to clear here, there are 2 types of incidence. One is cumulative incidence, where we take total number of new cases in a year by total population. Whereas there is an incidence density or incidence rate where we take the duration of follow-up. So numerator will be the number of the cases, but denominator will be the duration of follow-up. So in sometimes they give you duration of follow-up. Suppose 100 people are followed for 5 years. So it will become 500% years. So that will be the denominator in case of incidence density or incidence rate. But this question is very simple. Here number of cases are given, total population is given, and always calculate incidence rate per 1,000 population. So when you do calculation, write down your answer, write down the unit. So in these cases, incidence rate will be 11.11 cases per 1,000 population per year. So like this, you have to calculate the incidence rate. Now next is, in a city having population 5 lakhs, the incidence of diabetic mellitus is 6 per 1,000 population. So incidence is given and prevalence is 54 per 1,000 population. Calculate mean duration of diabetic mellitus. So first write down the given data. Prevalence is 54, total population is 5 lakhs, and total mean duration we have to calculate. So we know that there is a relationship between the prevalence and incidence. In terms of prevalence is equal to incidence into duration. So we need to calculate the duration of the disease. So duration will be equal to prevalence divided by incidence. So prevalence is 54, incidence 6, so it is 9. So what is 9? Duration. So you should write the duration of disease as 9 years. Then calculate the crude birth rate and crude death rate. Major population is 10 lakh. Live birth in the year is 32,000. Number of deaths are 9,500. So given data is live birth, death, median population, and we have to calculate crude birth rate and crude death rate. So crude birth rate is number of births divided by median population into 1,000. So we have to put up the values. Then it will be 42 births per 1,000 population per year. Don't forget to write down the unit of the crude birth rate. So it is the number of births per 1,000 population per year. Crude death rate is number of deaths divided by median population into 1,000. So 9,500 deaths are there. Population is again 10 lakhs into 1,000. So crude death rate is 9.5 deaths per 1,000 population per year. Don't forget to write this unit. It carries half mark. Now coming to the calculation of age-specific death rate, that is 0 to 5 years, and sex-specific death rate. So sex-specific will be for females death rate, then specific death rate for males. So males and females separately. And for age group or age specific, it can be 0 to 5 years, it can be 6 to 14 years, or it can be 15 to 29 years, or it can be 36 to 45 years. So any one of the age specific death rate and any one of the sex specific death rate can be asked. So here different age groups are given, how many deaths are there in the male and female, and these are the total female deaths, these are the total male deaths, and these are the median population of a specific age group. So in this question, they have asked us to calculate the sex-specific death rate for males. The number of male deaths by median population into 1,000. So 1270 is the total male deaths divided by 5,40,000 into 1,000. So 2.53 male deaths per 1,000 males per year. So this is sex-specific death rate for male. Likewise for females, number of females deaths median population into 1,000. So 2,040. These are the total female deaths. This is total female population multiplied by 1,000. So it will be 5 female deaths per 1,000 females per year. Now coming to age-specific death rate for 0 to 5 years. So number of deaths per person between 0 to 5 years, denominator will be median population of persons aged 0 to 5. So don't get confused here. you have to take the population of that particular age group, not the total population. So 610 are the deaths for male, female, both in the age group of 0 to 5 years. This is the population. So it is 2.54 deaths of persons aged 0 to 5 years per thousand median population of 0 to 5 years per year. So like this, you have to calculate the sex specific and age specific mortality. Now next is vital statistic, that is maternal mortality rate. So they have asked you to define what is maternal mortality rate. This is a 1 mark question. And then there are 30 women died due to purple sepsis and there were 8,000 live births. Incidental deaths were also given 20. So this is to confuse you. These 20 deaths are not counted for maternal mortality rate. So the given data is maternal death 30, incidental death 20, live births are 8,000. We have to calculate the maternal mortality rate. But before that, what is the definition of maternal mortality rate? It is the ratio of number of maternal deaths in an area to the total number of live births in the same area in given period of time, expressed as per 1,000 live births. So we need maternal death, we need live births into 1,000. So maternal mortality is the number of maternal deaths divided by total live births into 1,000. So 30 by 8,000 into 1,000 it comes to 3.75 maternal deaths per 1,000 live births per year. Now, for a town with 1 lakh population, there were 4,000 live births, 400 infant deaths in the year 2012, 120 infants that died within 28 days, means it is neonatal death, while 60 died within 7 days. So these are early neonatal deaths. There were 210 still births, so these are the births which have not shown any sign of life after birth. So they are called as still births. So what we have to calculate: infant mortality rate, perinatal mortality rate, neonatal mortality rate, post-neonatal mortality rate. So either 1 or 2 will be asked in your exam. So we need to write down the given data: live births 4,000, infant deaths are 400, neonatal deaths are 120, early neonatal deaths are 60. So you have to label them here. Then still births are 210 and median population is the 10 lakhs. So we have to calculate. So write down the formula: IMR is equal to infant deaths divided by live births into 1,000. So 400 infant deaths are there, 4,000 live births are there into 1,000. So it is 100 infant deaths. The next is neonatal mortality rate. So it is neonatal deaths by live births into 1,000. So neonatal deaths are 120. They died within 28 days. Divided by 4,000 into 1,000. So it is 30 neonatal deaths. So you can see here infant deaths 0 to 1 year there are 100 infant deaths. So neonatal deaths are 30, means first 28 days 30. So postnatal will be 100 minus 30. So it should come 70. Like this you can confirm your result. So this is post-neonatal mortality rate. So post-neonatal death, that is from 28 days to 1 year, divided by live births into 1,000. So 400 are the total births or infant deaths minus the neonatal death. So it will become post-neonatal death. So it comes to 280 divided by 4,000 into 1,000. So it is 70. So you can see here 70 plus 30 is equal to infant mortality rate. Now coming to the perinatal mortality rate. So here you have to take 2 types of death. One is late fetal death. So that is the stillbirth, and plus early neonatal death. So these are the deaths within first 7 days divided by live birth into 1,000. So 210 are the stillbirth, 60 are the early neonatal deaths. So it is total to 70 divided by 4,000 into 1,000. So 6.75 infant deaths or perinatal deaths per 1,000 live births per year. So like this you have to calculate. 1 or 2 of these will be asked in your exam. Now we have to calculate the abortion rate and abortion ratio for a town having population 11,000, 3,860 women in childbearing age, 110 live births, and abortion performed were 15. So there were 15 abortions, live births are 110, and women in the childbearing age out of 11,000 are 3,860. So this is the given data. Now we have to calculate the abortion rate and ratio. So rate, just remember like birth rate and death rate where we take median population. So it is the population of the women of childbearing age because they can undergo the abortion. So this denominator you should remember in case of rate. Numerator remains same for the abortion rate and ratio, that is number of abortions. So in case of abortion rate, number of abortions divided by women of childbearing age, or you can say it is the median population of the childbearing age into 1,000. So 15 by 2,000 into 16 into 1,000. It comes to 3.8 abortions per 1,000 women of childbearing age per year. Now coming to the abortion ratio, it is the number of abortions by live birth. So like maternal mortality rate, infant mortality rate, we take the denominator as live births. So in the abortion ratio also we take the live births as the denominator. So 15 are the abortions, 110 are the live births into 100. So it will come into percentage, whereas the abortion rate will come into per thousand population or per thousand women of childbearing age. So abortion ratio is the 13.63%. So differentiate between these two, don't get confused. Just remember rate is nothing but the median population, and ratio is the number of live births. Now, mortality data from a district with 10 lakh population is given. Malaria deaths are given, accidental deaths are given, deaths due to carcinoma. So we can calculate the specific death rate for malaria, for accident, for the cancer, and also crude death rate. Crude death rate will be the death rate for all deaths. So given data. So in a specific death rate for malaria, we have to take deaths by malaria divided by total population into. As the population of the district is 10 lakhs, you can multiply it either 1 lakh or 1,000. So specific death rate for malaria is 10 per lakh, 1 death per lakh population per year. Likewise, for death rate for accidents, number of deaths by accidents by total population into 1 lakh, so it is 115 by 10 lakhs into 1 lakh, that is 11.5 deaths per lakh population per year. Then specific death rate for cancer also. Likewise, we have to calculate, put up the values deaths by cancer by total population. So 30 deaths by cancer per lakh population per year. And last is a crude death rate, means you have to take the deaths by all diseases by total population. So it will come to 42.5 deaths per lakh population per year. So like this, you have to calculate specific death rate for particular disease. Now this is for the RNTCP data, where cases of tuberculosis are 3,000. New sputum cases are 700, cases discharged as cured are 540, and died during 2021 is 50. So we have to calculate case fatality rate and specific death rate due to tuberculosis. So case fatality means number of cases died out of total cases, and specific death rate by TB will be number of deaths by tuberculosis by million population into 1,000. So population is 3 lakhs, cases are 3,000, new sputum cases are 700, cases discharged as cured are 540. So total cases are 3,700. So 540 are discharged, so we are not concerned with this, and total cases died are 50. So case fatality rate is the number of deaths by TB by total cases of TB. So case fatality, so you have to take here the total cases. So 50 by 700 into 100 is equal to 7.14%. Then specific death rate due to tuberculosis is the number of deaths by TB by total population. So here don't take total number of cases, that will become the case fatality. So for the specific death rate means you will take the median population. So number of deaths by TB are 50 divided by 3 lakhs into 1,000, so it comes to 0.166 deaths by TB per 1,000 population per year. Then this is another example of secondary attack rate. A community has 100 children, out of whom 28 are immunized against measles. So measles is 100% effective vaccine. 2 of them acquire measles simultaneously. Subsequently, 14 get measles. Assuming the efficacy of the vaccine to be 100%, calculate secondary attack rate. So total children are 100, immunized are 28. So it means that 72 are susceptible. So out of 72, 2 are primary cases. First 2 people, they suffered from the disease, so they doesn't remain susceptible after getting the infection. So 72 minus 2 comes to the 70. So 72 minus 2 is equal to 70. So these are the people who are susceptible to attract measles from these 2 primary cases. So like this, these are the given data given in this question. The total children are 100, 22 are immunized, means they are protected against measles. So 100 minus 28 is equal to 72. Out of 72, 2 cases develop the disease, so they are primary cases. So 70 remains the susceptible population. So the formula for calculation of secondary attack rate is number of secondary cases. Primary cases are not included here, divided by susceptible children, so which are 70. So put up the values 14 by 70 into 100, so it is the 20%. Secondary attack rate is always calculated in percentage. You need to multiply with 100 and answer will be in the percentage. So this is the example of secondary attack rate. They may ask you to interpret also. So if it is like 5%, 10% is the low, means low rate of transmission is very low. Whereas if the secondary attack rate is 70, 80 or 90%, then the rate of transmission is very high. Like this we have to interpret. Now coming to a PSC covering 18,000 population, the data for year 2020 under National Anti-Malaria Program. So total slides examined are 2,500. Slides positive for malarial parasites are 131, and out of this 131, positive for falciparum are 24. So we should not combine these two. Out of 134, 24 are falciparum, rest of them are other malaria. Now what we have to calculate? Annual parasite incidence, annual blood examination rate, annual falciparum rate, and or incidence, and slide positivity rate. So these are the four things which we have to calculate. So we need to write down the formula. So given data is population 18,000, total slides examined are 2,500. Out of this 2,500, 131 are positive, and out of 131, 24 are positive for falciparum. So annual parasite incidence is equal to number of parasite positive slides divided by population under surveillance. So this population we have to take here. So multiplied by 1,000. So API is calculated per 1,000 population. So 131 total are positive. Don't add 24 here because 24 is out of 134. Sometimes some students they get confused and they add 24 also. So 24 is not required here. 131 is the total positive for malaria. Divided by population 18,000 into 1,000, so it comes to 7.2 cases per 1,000 population per year. So this is like an incidence rate, but it is for annual parasite incidence. Now next is annual falciparum incidence. So here we have to take number of falciparum positive by population under surveillance. So it is 24 by 18,000 into 1,000. So it comes to 1.3 falciparum cases per 1,000 population per year. Now next is annual blood examination rate. Blood examination rate. So numerator will be number of slides examined. Then because it is also rate, so population under surveillance into 1,000. So 2,500 slides were examined out of 18,000 population into 1,000. So it comes to 138 slides examined per 1,000 population. Like this, you have to calculate annual blood examination rate. Now come to slide positivity rate. Means how many slides are positive. Out of them, how many are positive. How many slides are examined and how many of them are positive. So number of slides positive divided by number of slides examined. So 131 were positive out of 2,500. You have to multiply this with 100 because the answer is in percentage. So it is 5.24% positivity rate for the slides examined from the total slides. So like this, these are the parameters of malaria surveillance which are asked in your exam. They may ask you one and interpret, or they may ask you to calculate two also for 2 marks. Now coming to the given data, calculates odds ratio. Now this is a case control study where cases are given, controls are given, those who are exposed, those who are not exposed, they are also given. So again, it is like contingency table 2 by 2. So first row is the AB, second row is CD. So please remember this ABCD because based on these ABCD values, only you have to calculate the odds ratio. So odds ratio is AD by BC, write down the values, multiply them, use calculator. Now odds ratio came to 10.79. Now we need to interpret or comment. So comment will be the odds of development of lung cancer among smokers is 10.79 times higher than the non-smokers. So mention the odds ratio, and you should always mention the chance of development among exposed compared to the chance of development of disease among non-smokers. Now this is the cohort study. Cohort study, here again they have given 2 by 2 table. Now we have to calculate relative risk, attributable risk, and population attributable risk. So these are 3 things which we need to calculate, which we usually calculate in case of a cohort study. So here the cases are there among exposed are 50, non-smokers are 4 cases, total cases are 54. And the number of cases, no cancer are 950 who are exposed and 996 who are not exposed. So no cancer are 1946 and 54 are cancer cases, and total population is 1,000. Exposed population is 1,000, non-exposed population is 1,000. Now we need to calculate the incidence rate, relative risk, attributable risk, and population attributable risk. For relative risk, we need incidence among exposed by incidence among non-exposed. So first we need to calculate. So these are the formulas which are used. Attributable risk is incidence among exposed minus incidence among non-exposed divided by incidence among exposed. And population attributable risk is incidence of disease among total population. minus incidence among non-exposed divided by incidence among exposed into 100, which actually we have 200 have come, but it is only 100. So these are the three formulas. So what we need incidence among exposed, we need incidence among non-exposed, we need incidence among the total population. If we have all these three values, we can calculate these three parameters. So incidence among exposed is the number of cases exposed by total population which is exposed into 1000. So 50 are the cases among exposed and 1000 is the total population which are exposed into 1000. So 50 cases per 1000 population per year is the incidence among exposed. Likewise, we have to calculate incidence among non-exposed. So number of cases among non-exposed divided by total population which is non-exposed into 1000. So 4 into 1000 by 1000. So it comes to 4 cases per 1000 population per year. So this is the incidence among exposed 50 and incidence among non-exposed is 4. Now we have to calculate the incidence in the total population. So our total population is 2000 and total cases are 54 in both exposed and non-exposed. So 54 are the total cases divided by 1000 into 1 divided by 2000 actually, and it is a multiplier 1000. So 54 by 2000 into 1000 is the correct formula, and after putting the values, and we have to calculate the incidence among exposed. So now we got incidence among exposed, incidence among non-exposed, and incidence among total population. Now we have to put up all these values in our required parameters. Relative risk incidence among exposed is 50, incidence among non-exposed is 4. So relative risk is 12.5. So in some question, they may ask you to calculate the relative risk and interpret. So relative risk is 12.5 and interpretation will be the chance of development of disease among exposed is 12.5 times higher than the chance of development of disease among non-exposed. Like this, you have to write down completely. Coming to attributable risk, it is the incidence among exposed minus incidence among non-exposed divided by incidence among exposed into 100. So 50 minus 4 divided by 50 into 100. So it comes to 92%. So 92% of the disease can be attributed to the smoking or to the exposure. And last is the population attributable risk. Here incidence among total population minus incidence among non-exposed divided by incidence among exposed. So 27 is the incidence in total population minus 24 divided by 50 into 100. So like this, we have to calculate the population attributable risk. It means that if we remove the risk factor, 46% of the disease can be prevented in the total population. Our next question is calculate requirement of bleaching powder for disinfection of well. So you have a well and you want to disinfect it, and it is having the height of 7 meters and height of water column in the well is 5.5 meters and radius is 2.5 meters. So these are the given information. Height of the well is 7 meters, height of water column is 5.5 meters, radius of the well is 2.5 meters, diameter of the well is 5 meters. Bleaching powder required of the well. So what we need the volume of water in the well. So the formula for volume of water in the well is 1.1 by 4 pi into diameter square into height of water column, not the height of the well. It is the height of the water column into 1000. So it is 3.14 into diameter square into height of the water column into 1000 by 4. So 3.1.4, 5 is the 2.5 is the radius, so diameter will be 5. So 5 square into 5.5, it is the height of the column of the water into 1000 by 4. So it comes to 1,07,937 liters of water is present in this well. And we know that if we have a good quality bleaching powder, that is 33% free chlorine is present in the bleaching powder, 2.5 grams of that bleaching powder is required to disinfect 1000 liters. So how much will be required for disinfection of the 1,07,937 liters? So it is around 269 or 270 grams of bleaching powder is required to disinfect the well. So please don't get confused with the height of the water well with the height of the well. Now next is the calculate the monthly vaccine requirement of tetanus toxoid, BCG and measles of a PSC with population of 45,000 having a crude birth rate of 24 per thousand population and infant mortality rate 74 per thousand population. So here what we need, TT is given in pregnant mothers, so we need to find out how many pregnant mothers are there, and this BCG and measles are given to the infants less than 1 year. So we need the population for this infants less than 1 year. So pregnant mothers is total population into birth rate, and infants population is equal to total population into birth rate into 1 minus infant mortality rate. So like this, we can calculate number of pregnant mothers and number of infants. Now vaccine requirement is equal to, the formula is number of beneficiaries into number of doses of the vaccine into wastage multiplier factor. So wastage multiplier factor for various vaccines are BCG is 2, DPT, OPV, TT is 1.33. So we have to put up these values whenever we are calculating the vaccine requirement for particular vaccine. That is the wastage multiplier factor. So now coming to the TT requirement, pregnant mothers, how many are there? Total population is 45,000 into birth rate is 24 divided by 1000. So it comes to 1080 pregnant mothers are there. So TT requirement will be number of beneficiaries are 1080, number of doses are 2 for the vaccine, and wastage multiplier factor is 1.33 for the TT. So it comes to 2,872 TT doses. So there are 10 doses per vial, so you need to divide this by 10. So it comes to 288 vials required per month for vaccinating the tetanus toxoid vaccine in the pregnant mothers. Now, infants, how many number of infants are there? Total population into birth rate into 1 minus I month. So it is 45,000 population. 24 is the birth rate divided by 1,000 into 1 minus 74 by 1,000. So it comes to 1,000. So total 1,000 infants are there. So how many vaccines or vials are required for vaccination of BCG? It is the number of beneficiaries, that is 1,000. Number of doses for BCG are 1, and the vaccine wastage multiplier factor for BCG is 2. So we have to put up the values. So it is 2,000 doses. So per vial 20 doses are available because we give this vaccine in a dose of 0.5 ml. So 10 ml vial is available. So 20 doses can be given in one vial. So we need 100 vials for giving the vaccination of BCG to the 1,000 infants. Now coming to the vaccine requirement for DPT vaccine. So how many doses are given for DPT vaccine? We primary immunization, we give 3 doses and booster dose is 1. So number of beneficiaries are 1,000, number of doses are 4, wastage multiplier factor is 1.33, so it comes to 5,320 doses. So in each dose, 5 ml vial is there, which gives 10 doses. So you need to divide this 5,320 by the 10, so it comes to 532 vials are required for giving vaccination against DPT to the children. So like this, we calculate the vaccination. Now coming for the OPV, again, number of doses are 3. So put up the number of infants is 1,000, number of doses 3, wastage multiplier factor 1.33. So it comes to 3,990. So almost 399 vials are required. So like this, we calculate the vaccination. So these are the some of the questions which are asked in your practical examination for epidemiological exercises. Please write down the formulas for all these exercises, learn them, because you need to know the exact formula and you need to know how to put up the values from the question given and what need to be calculated and the interpretation. So like this, you do read the question carefully, first write down the given information in the question and what is to be calculated, that you write down, then you write down the formula for calculation of particular thing which is asked in the exam, then write all the values, calculate the answer, write down the unit also, and write the complete answer. So like this, you have to calculate and you have to do the epidemiological exercises and biostatistics exercises also. So this all epidemiological and biological and biostatistics exercises will be sufficient for your practical examination of doing exercises of statistics and biostats and epidemiology. So I hope that this video will be helpful for you for your practical examination. All the best for the exam, and thank you very much for watching this complete video.